So welcome everyone. Thank you so much. This is the very first of the meetup events for Democratize Data. Just to briefly introduce, I'm Sandeep. I lead data for Intuit's 3 billion franchisee called QuickBooks. The name of our team is Quick Data, and the focus essentially is all the way from transactional databases to big data fabric to business KPIs. So, it's a whole gamut of things that Quick Data covers. The mantra for the team ever since its inception has been democratizing data. What that basically means is how do we truly unlock the value that data has and make it accessible to everyone within the organization, right? As all of you are aware, to harness the value of data, it's not just limited to data scientists and analysts, but pretty much everyone from product managers, marketers, sales, everyone can now leverage and harness. So our mission has been to build a platform, and this meetup essentially is all about getting the best in the industry in the domain of how are you making things self-serve, right? So this is definitely the first of the series. You'll have follow-up series and talks. We're aiming to do one every month. The very first of this essentially is focusing on data lineage and monitoring anomalies. So these two topics, in fact, we are very fortunate to basically have both these topics covered. So I'll start with the first topic. It's Superglue. This is the framework that we've developed at Intuit, given the bigger mantra of self-serve. To present Superglue, I want to introduce Sunil. Sunil Goplani has been the lead, has been leading the team. Superglue actually was his brainchild right from the very beginning. And along with him, we have Shraddha. Shraddha is the lead engineer working on this effort. And there's something very interesting lined up. So take it away, guys. Thank you.
Thanks, Sandeep, for the introductions. To start with, I just want to get a poll of how many people in the audience are either data engineers, analysts, or data scientists. Okay, fair bunch. You guys will be able to relate to a lot of things that we are going to talk about today. To introduce Superglue, we are going to use some examples. So we are going to walk you through features of Superglue through some examples. So let's just straight jump into that. So this is a dashboard. Obviously, we have actually hidden the numbers. We cannot show that to you. This is a marketing OA acquisition dashboard. So this dashboard is talking about how much money is being spent on OA channel, how many impressions, clicks, conversions, so on and so forth. Now, when this report came out for a specific week, the analyst who is closer to the business came back and said that this number doesn't look right. It's the number is underreported. Looks like something is wrong because they have access to the forecast data. They have access to business. There's the pulse of the business. Somebody tells them this is something wrong. I don't know whether this number is correct. And I'm sure many of you have dealt with this because you as a data engineer, if you are providing data to analytics teams, or if you are an analyst and you are processing data, when somebody from business comes and says, this doesn't look right, you are wondering, where do I start, right? What could have gone wrong? So there are many questions that come to your mind, or these are the questions you are being asked by someone, right? What went wrong? Why did it fail? Where did it fail? Who owns it, right? What is the impact? How soon will I be able to fix it? There's so many questions around it. Now, how do you figure out where the problem is? Now, if the problem is with your own process, it's easy to fix, it's easy to solve. But the reality in current world, right? We are dealing with big data. We are dealing with so many people who are playing with data, working with data. What happens is you are writing a process that's depending on data that is owned by someone else. And there are layers and layers of processing that happens. It's possible that when that number is not looking right, it's not your process which has caused that, right? It could be something upstream. It could be anything. There are so many things that can fail. Now, if you look at a few examples, this is just few examples, right? There's so many things that can go wrong when you are working with data, right? There could be operational issues, as I explained, right? Your job fails, you can easily fix it, but the failures could be upstream. Uh, Failures could be because there are delays upstream and you have not put right dependencies on your jobs on the upstream jobs, right? The issue could be with product is continuously evolving. Product is making changes. When they make the change, it actually impacts the data. And you are unaware that there has been change in the data. You are just uh, you're running your processes based on the assumption that everything is the same. But things are changing continuously. Things are evolving. You are not aware of it. That could cause that failure. There could be infrastructure failures. There are upstream ingestion jobs which are bringing in raw data, and that raw data is partially pulled in because there was a failure in upstream ingestion jobs. And we'll talk through some of these scenarios as well. So I'm just giving you a few examples. So anything could go wrong. How do you detect these issues, right? How do you help analysts, data scientists, or data workers, people who are working with data? How do you give them the visibility? Where is the failure? So let's look at that, right? The example that I showed you, it was an underreported metric. Let's see how Superglue helps detect those issues. Handing over to Shraddha.
Thank you, Sunil. So let's look at the Superglue. So here's the Superglue portal, and here you can come and search for a job, a report, or a table. So let's search for the table where the problem was. So it's a Tableau report. Let's search for it. So what you see on this screen is the lineage for this particular report. So the circle shape here represents a report. The ellipse shape here represents jobs, and the rectangular shape here represents tables. So let's look at depth 1. So the way to interpret this lineage is this report is being produced from this particular tables. Now if I go to level 2, there you'll see that these tables are input to this particular job, which produces these tables, and these tables are input to this report. So how we have derived the lineage? So we have passed the sequels in the Git repos, as well as from the scheduler, we are capturing the job definition and the execution stats. And we are also passing the shell scripts and the Python scripts which the SQL scripts through which the SQL scripts are being invoked, and then we are tying together dynamically on the fly to generate the lineage. We are also supporting both ClickView as well as Tableau reports, and the way we are deriving lineage for Tableau is we are calling Tableau APIs and downloading the XMLs and parsing the XMLs to derive lineage, and for ClickView we are parsing the logs. So along with this report, along with the lineage, we are also surfacing some of the stats. Like for a report, we are surfacing like last refresh stats. For a table, you would see table stats for that table. So all the stats, we are capturing it, we are getting it from the platform. So here the x-axis represents the date. The y-axis here bar graph, it represents the row count as well, and the bar and the line chart here represents the size. And all the stats we are collecting it from Vertica as well as these are the two main platforms where our ETLs are running. And for a job, we are also capturing the execution stats. The x-axis here represents the date and the y-axis here represents the start time. So along with the lineage, we are capturing the stats so that it can help us debug the information, debug the problem. Now, the report that Sunil was showing had an issue on the second week of August. So let's look at the lineage for 16th. So let's try to debug it together. So if I am looking at the lineage on 16th, until depth 2, it all looks good. The job seems to have completed normally. Now let's go back to depth 3. So the input table, so when we went to depth 3, the input, we were finding the lineage for all the inputs to depth 2. So at depth level 3 also, it looks fine. There is one more job. It seems to be completed normally. So it's all good until now. Now let's look at depth 4. Okay, so now you see something here. There is one job which seems to have completed abnormally. So along with, so as I mentioned, that along with the job, we are also surfacing the stats. So a job status, so the color here represents the status of the job. So green means completed normally and red means it failed. So let's look at the stats for this particular job. Okay, so this seems to have been failing consistently from 14. Let's try to go back and see 10th and let's submit. Okay, so from 14 to 21st, this job has been failing, but from 10 to 13 it was fine, and again it was fine. So there was something happening in that week. So let's look at the developer. So since we are capturing all this execution stats and job definition, we also has a reference to the SQL file, and then we are calling the get APIs. So if I click on this link, I can go back to the get check-in, because sometimes it happens that there is a ETL logic change that you have done, and that can also break the pipeline. And then now I know that it's Ashwin's job, and then I can reach out to him. So probably it could happen that from 14 to 21st he was on vacation and it just went unnoticed. Also, because you don't want this to happen in production, right? I mean, if person goes on vacation, job fails, you don't want that. So now if I want to monitor this job, then I can also, we are also released a feature where you can subscribe. So if I click on this job and I subscribe, so since Superglue uses SSO login, it already has my email, but I can add others also as subscribers and I can submit. And then I can go back to my account and can see for subscriptions, this was the job, and by default it subscribes you for failure. So next time the job fails, I would get an email notification. So what you saw until now was just like depth 4, but I want to show you how complex a dashboard is, and what Sunil was mentioning, how complex our pipelines are. So let's look at the full lineage for this particular dashboard. So since we are parsing all the SQL scripts, joining it all together, so it's the graph is generated on the fly. So you can see the huge lineage for this particular table, for this particular dashboard. And as you see from this lineages, it was not just one job that has contributed to the failure, but there were 5 other jobs which has contributed. So imagine if a dashboard, if I'm owning this dashboard and if I have to debug, if it's the first job, it's very straightforward. But if the failure is an upstream, and it could be anywhere, if I have to go and debug, it will take me like days and hours. But with Superglue, it just took me like few minutes to debug. So that's the debugging capabilities.
Thanks, Shraddha. So before I move on to the next example, right? So we are going to walk you through some of these features through examples, and that's how you would be able to, understand why these features came into life. But before I do that, let me talk a little bit about Intuit. So we are a company with revenue of $6 billion, and we have about 50 million customers. So we are operating globally, 20 different locations. And with 50 million customers, you can imagine there's lots and lots of data that we deal with. Our mantra at Intuit is to powering prosperity around the world. And the way we say it is with power of many, prosperity for one. I'm probably not saying it right. But the objective is we have 50 million customers. We have lots of their data. What it means is we want to use the data of these customers to help our customers save that save money, right? So that's how we are helping prosper our customers. So that's our mantra. Now, if you are looking at 50 million customers, the scale is really, really big. We are in petabytes of scale. Let's look at the data pipeline architecture. And this is a very simplistic view of our data pipelines. And I'm sure if you are data engineers, analysts, or data scientists, you have one way or the other dealt with this kind of architecture where there's lots of data that is being ingested from source systems. Here at Intuit, we are talking of about hundreds and hundreds of sources. The data could be related to product, it could be related to your enterprise software, it could be related to billing systems, data coming from third parties. You are definitely dealing with marketing partners and stuff like that. You're also capturing lots of behavioral data because you want to continuously evolve and make your product better. All this data gets ingested through ingestion frameworks or ingestion tools. Right? It could be real-time ingestion, it could be batch ingestion, and you'd put this data in a data lake. We are in AWS, so we are putting all our data into S3. There's lots and lots of data that's coming in as raw data from source systems. And there's tons and tons of processing also that happens there. And we use Spark, we use Hadoop-based systems, distributed systems to do lots and lots of big data processing in the data lake. And then this data gets loaded into MPP systems, or it could be any analytical OLAP system, which you would use to do reporting off of, right? Using reporting tools like Tableau and ClickView. But if we talk about scale, the complexity, as I mentioned, there are hundreds and hundreds of sources. What we are talking about here is thousands of tables. There are thousands of tables, there are thousands of dashboards, there are thousands of jobs and scripts that hundreds of users are running. How do you deal with that complexity, right? As I mentioned, there could be many failures. And the failures are not related to your jobs. It could be tons of other reasons, and you want to figure out where the failure is. In the first example that we used, if we did not have Superglue, it would take these hundreds of users spending so much of time every day when things fail. And every day something is going to fail, and that's the reality. Then they were spending tons and tons of many hours, tons and tons of hours debugging, right? And that's the problem that we wanted to solve. Our objective, our mantra for Superglue was to, reduce the time to debug and increase the time to insights. And that's how Superglue came to life. That's how we are building these self-serve platforms. Okay. With that, I will take another example. This is another example of a dashboard. Obviously, you cannot see the numbers, but this is a dashboard where the dashboard came out for a specific week. There was no data. Now, when this happens, it's a similar problem. You're asking the same questions, right? What went wrong? Where did it fail? Who owns it? And how do I fix it? How fast can I recover from this? Let's see how Superglue helps here as well.
So coming back to Superglue portal. So now let's search for this dashboard. So again, this is a Tableau report. Let's search for it. So what you see here on the screen is the lineage for this dashboard. Now this is a weekly dashboard and this issue was seen on 12th. So let's look at the lineage on 12th. So this dashboard is being produced by this particular job. So let's look at the execution stats for this job. So let me go back, submit. So now if I look at the execution stats for this job, it seems that this job refreshes every day at 9:30. But it is also recommending some of the missing dependencies. So now since we are parsing all the SQLs from Get and we are tying it with the job definitions, we know exactly what the dependencies your job need. But as an analyst or any engineer who says joins the company, or based on this complex lineage that you have seen, an analyst may not know what are the right dependencies, and they may not add the dependencies. So what would that mean? In that case, your job could execute without your dependent tables being refreshed, and that could lead to a data quality issue. So along with, so what you were seeing right until now was the table lineage. So let's look at the scheduler lineage for this particular table, for this particular job. Since this is a weekly job, so here you would see the scheduler lineage is purely based on what dependencies you have set it on the scheduler. So for us, we are using title. So now what you see here is it is only dependent on one particular job, QBSC user status billing. But from a dependency recommendation, it is giving me 4 other dependencies, and it is showing me it is dependent on a weekly job. So let's go to level 3 for this, so that in the table lineage, it would show these jobs. Let me zoom in. So let's look at the execution stats for this job. And on 10th, you would see that this particular job completed at 10:44, but the dashboard job was refreshed at 9:30, and that's the reason why you have missing data. So a missing dependency could lead to data quality issues. So we had analyzed critical dashboards, and we found that 90% of the critical dashboards or the jobs were missing dependencies, and which could lead to data quality issues. So prior to Superglue, it was like either we'd see a dip in business metric or somebody would report. But Superglue offers you, with this dependency recommendation feature, it offers you a capability to proactively monitor your jobs. Now, one of the thing is also that if this dashboard job ran prematurely, you would also want to see how many other dashboards it could also impact. So there we have the forward lineage feature as well. So this is like depth 1. So it was just not QBSC funnel dashboard which was impacted, but it was QBSC account dashboard which was also impacted on 12th. So
Thanks. Thanks, Shraddha. Now that you mentioned about forward lineage, you want to talk about the use case where forward lineage could be extremely useful?
Yes. So this was one particular scenario where we looked at the forward lineage for job. Now, as like Sunil was talking about the ingestion pipelines, and the source for that starts from the source tables and then it moves into data lake. Now, the PD teams, as our business is growing, the PD teams are constantly making modifications to the tables and schemas, and also we want to assess immediately if that will break any of the downstream analytics. So let's look at one of that use case. So let me search for a source table. So this is a table, a source table, which is being ingested into data lake. And if I go to lineage 2, so now we will see that this particular source table is used further downstream in analytics. Further jobs and tables are using them. And level 3 and level 4, and where you would see all the reports also using this table. So our ops team are leveraging Superglue. So anytime you detect or anytime you see that there is a DDL change, or you see that the tables are being, or anybody is executing a drop statement, you can leverage Superglue portal to see the impact. And this process is already in production. It's not only just for the PD teams, but anywhere in the ingestion pipeline, any data engineer or analyst who's trying to make a change can leverage this feature to assess the impact. And also all this functionality is also exposed by APIs. The lineage for this is pretty big, so I'll use an API to demonstrate that. So say if we have to assess how many reports it is impacting. So if I will just look at the ClickView reports, it's 2. And then if I look at the Tableau reports, it is 272. So anytime you make a change to any schema, or any detail modifications, it could impact up to 275 reports. So with the help of Superglue, you can do easy impact analysis.
So this example was where we actually took one of the critical tables, and what Shraddha was trying to show is that any change, a schema evolution or a DDL change on that table could impact so many downstream analytical reports. And you must have seen in real world, right? Product development teams are making changes in their own world, in their own schemas, not realizing that they are going to actually break lots of analytics. And analytics is actually feeding business with their business insights. So we are trying to avoid those kind of breaking changes, and the API basically helps the DBA teams that whenever there is a schema change that's coming in a development environment or a test environment, what they do is they hit our API and they look, is it a breaking change? If it is, then they block the change to go into production in their own systems. Cool. So that was that demo. Let's look at the next one. Let's look at this use case. In this use case, it's very easy to explain from this chart. You basically are seeing actuals, and in this example, we are basically looking at the total customers, total gross new subscribers that we get. And it's obvious that any business user or an analyst will say there's a dip in this metric. And when we looked at the jobs that were feeding these dashboard, everything looked great. The jobs were running successfully. Let's see how Superglue detects what was wrong with that.
So coming back to Superglue portal, so like what as Sunil mentioned, the report showed a dip, and this is one of the most important report for SBSEG. So Superglue also has a link on the portal, critical reports, that has all the list of the critical reports, so you don't have to even go to search and type. So let's look at the lineage for this particular report. And then we can go back in time. So this particular issue was on 22nd. If we look at the full lineage, what Sunil was pointing that it all seemed good. So then how do we debug? So I'll just flash the full lineage for this particular report. Now, along with what I had mentioned in my first demo was that along with the lineage, we are also collecting some stats. So we are collecting stats for a table and for a job. And as part of ingestion, we are also running these stats through a bunch of machine learning algorithms. And the stats, like for a table, we are collecting row count, size, and we are also doing some anomaly on columns like non-null count, cardinality. So we, as part of ingestion, we run it through a bunch of machine learning algorithms, and we capture those results. So, and those results can be surfaced through the Superglue portal. So what you have, the new feature that we introduced is anomaly reports. Now I can come to, and if we see any anomalies, it also triggers a PagerDuty alert. So a person who's on call can come here and look for the anomalies. So let's look at on 22nd. So on 22nd, there were two major anomalies. So let's look at the first one. So this is here, these are the details. So this means that on 22nd, the total row count was this, but it says +0 compared to yesterday. That means that there was no new data brought on 22nd. So and when you detect anomalies, it could be false alerts as well as it could be true anomalies, and then you have to go and debug it. So let's see if it's a valid anomaly or not. So you can go back now on from this screen, you can go back and see what's the lineage for this particular table. And let's look at the stats for this particular table. So on 22nd, it on 22nd there was zero increase in row count, and on 21st also it's the same. So the row count is same on 21st and 22nd, so it definitely seems an anomaly. And also, if we look at the last refresh time, it was 4:35. So that means there has been a DML activity on the table, but no new data has been brought. Now let's see if it impacts any of the critical tables or any of the critical reports. So let's look at the forward lineage for this particular level 1. Okay, it seems it is being used by multiple pipelines. It's already being used by ClickView report. It seems to have been used by ClickView reports. Um, I can also automate it by my APIs, as my ingestion pipeline is running. As soon as I detect an anomaly, I can call the forward lineage API and then see. So let me look at the forward lineage. So this is the full forward lineage of this is also pretty big. Now let's search for how many Tableau reports. Oh wow, this table impacts 495 Tableau reports. And if I look at ClickView, so 10 ClickView reports. So I mean, it's going to definitely affect business. So it's a true anomaly. I can add my comments here, and I can view um, others' comments. And if I'm entering all these details and if I don't enter a comment, it also gives me a warning message, as well as I can view other comments, and then I can submit. And all this information that we are entering here, it goes as a feedback loop back to the training. And since we have persisted all this information, we can also do trend charts that to see how many anomalies was reported on that particular day, and then how many times this table has been detected as an anomaly. Also, now what you see was the anomaly screen, and also since we have the subscription feature available, I can also subscribe that in future. I can come to this portal and say I want to subscribe for anomalies for this table, and I can go and subscribe, and I can subscribe my manager as well. And then I submit. And if I again go back to my account, so I would see that I'm subscribed for this table. So by default, it is failure, but yeah, you can select here for anomalies. And then next time, whenever you detect an anomaly, you will get an email notification. So earlier it used to be all manual process, and with Superglue, we have automated the entire process, and you can catch issues in minutes, which used to take hours and days.
Thanks, Shraddha. That this parallel environment that we have set up is going to give you the same metrics that you are making decisions on today in production. So it was very important for us to give them the frameworks and automation and tooling so that they are successfully able to compare the metrics in AWS against metrics that are coming out of our data center. For that, we built few more automation tools, but I'll tell you the story how Superglue helped. So we had to compare the metrics that are coming out of AWS as well as our data center. We built a simple UAT tool or automation tool, which would run these queries against both the environments, collect the metrics, and compare the metrics. So it was comparing the metrics against both the environments, comparing the data against both the environments. But imagine that you have this information for thousands and thousands of tables. How do you ask users to sign off on the thousands of dashboards? So we had to actually scope it down. We went to business and said, can you tell us what is the most critical dashboards that you have that you would like to sign off? They said 400 plus dashboards, right? So how do you then get a sign off from business and analytics for 400 plus dashboards? That's where we used Superglue. What we did is we collect the metrics that we were collecting, which were comparing metrics from AWS to our data center. We overlaid those metrics on our lineage that was coming out of Superglue. So consider Superglue or the lineage as the backbone. And what you have seen so far is execution stats, data profiling stats. Similarly, we overlaid the data quality metrics that were coming out of these two environments on that backbone, which is the lineage. What that did for us is that every time users were comparing the dashboards, obviously manually it was becoming very difficult. When they saw a difference in the metric, because we had the metric validation framework that we had built, and we see this gross new subscriber metric does not look right for yesterday. AWS, it's looking low compared to data center data that's coming in. We were easily able to backtrack and pinpoint exactly which is the process that has not run in AWS environment, and that's the reason this metric is not matching. Similarly, when we had issues with upstream data that's coming into AWS and it had an issue, we were able to see which dashboards is it going to have issues on, so that we would ask users not to actually look at those dashboards which are not yet ready. So we were using our lineage as a tool to traverse between all these data issues that were going on while we were running these two parallel environments. And the outcome of all this that we enabled through automation was that within 16 days, we were able to get a sign off from business for 400 plus dashboards. So that's just another success story how Superglue could be used for different things. Thank you. So with that, we wanted to share the love, right? All the great things that we were doing. We see the potential of what we had built that can be used in so many scenarios. And that's why we open source this tool. So it is available. You can find this on GitHub. And Shraddha, maybe you can touch upon and talk about what folks can find on that GitHub link.
Yeah, so it's very straightforward. So once you go to the GitHub link, it has a very detailed README, and it already comes with a Docker container. It has all the services which are required by Superglue, and it also comes with a sample data set. So it just takes like 5 minutes to set up, install. So I would highly recommend all of you to try it out and reach out to us. So the README also has, and then we have a contact page also. So reach out to us for any questions.
Cool, thanks. I'm sure lots of you guys are dealing with similar issues. And if you see there's a usage and there are use cases that you can bring and we can enable those through Superglue, we'd definitely like to partner. Well, we definitely encourage that you be the committers, and then we would make this journey happen together. With that, I just want to summarize the features that you saw. We looked at the demo for the operational issues. We looked at anomaly use case. We also looked at source changes. This list of features that you saw today. The features that are listed in bold there are the features that are available in open source. Lots of stuff that you saw today is in our enterprise version, but as we open source, slowly we are migrating and making these features available in the open source, right? So if you want to be part of that journey, please partner with us, and we will make this happen together. Okay. With that, I will open it up for questions. Just few team pictures, right? Along with all the cool stuff that we are building, we also celebrate our teams as well as our wins. So we are open for any questions you have. Thank you.
you're migrating from different databases, right? Like, or say like you have your in-house ETL tools, all right? Say, and this is a new framework which you are doing migrating it to. So how do you actually capture the say success of a job or a state of a job, and because that serves as the metadata for the this tool, right? So and if it goes across different tools, say like use Hive, use Informatica, or use different ETL tools, like how do you actually do that? So,
Very good question. So the way we are enabling that, the way we look at Superglue, it is not for the tools that we are using. We are in fact building it in a way that you would be able to, we are building adapters. So for an example, today it's Tidal, but tomorrow you are using Control M or you are using Airflow, right? As far as you are able to collect these statistics from those workflow tools or orchestration and workflow tools, as far as those those metrics and stats are available and exposed into Superglue, you would get to see the lineage as well as the same interface. So the interface remains the same. We are exposing that through adapters and APIs. So you would also have APIs. We are building APIs as well. So imagine that you are collecting these stats, whether those are table stats or job stats or execution stats. We are publishing those through these APIs, and those are available on Superglue.
So as of now, like means you are parsing only the Vertica data, like the Vertica as a, like your database. But let's say if I have like a different database, or consider that like Vertica would be upgraded and it is going to provide you the data into the different form, the logs. How you are going to parse those data, like means how easy to like means enable those features into Superglue. And the another question is, let's say I am doing the only the file processing, where I'm going to just parse the file in terms of the shell script or the different scripting language, where I'm going to like means have source file and load the data into the different file. How you are going to identify that? And the third question is, um, go for it. Long, or because of that also means you are kind of seeing the data anomaly. So are you also trying to collect those information as well?
Yeah. So the first question, your first question was that it's not just supporting Vertica, but it supports Hive as well. And what we are using is we are internally using the licensed GSQL parser and Apache Calcite parser, and they support both Vertica and Hive, and they have connectors for other platform as well. So as long as the underlying SQL parser engines are supporting, it's all good. And also, it could happen in some of the cases where it could be a very complex CTL script, and there are scenarios also where we are not able to parse it. So in that cases, we are also working on providing REST endpoints, where as a client, you should be able to publish the processing.
And that's the answer for your second question, which is, say, for an example, you are doing some file processing. If you don't want to say write parser for it, the other way to publish the lineage is through the endpoint that Shraddha mentioned, right? So you tell Superglue that this is my lineage, right? This is my process. These are my input tables and these are the output tables. As far as that is published, it can then stitch and attach to the rest of the lineage. And your third question was?
Yeah, third question was, I think, execution stats if my job is running for a long time. So yeah, I must mention we are doing anomaly on the job duration as well as the start time. So if your job is running for a long time, it's an anomalous.
But to answer your question as well, is that right now we are pulling tidal stats every 15 minutes, right? So for an example, your job is running for a longer period of time. We continuously have that feed coming in. So if you see the architecture diagram, there's a feed coming from these execution stats through Spark into Superglue, right? So it would be depending on the adapter, you can actually collect all that data and feed it into Superglue as frequent as you want.
So in your last demo, you showed that there's an anomaly in the report, right, or in the chart. So you have thousands of reports, and each report have many metrics. Do you automatically monitor all of this, or is it by demand that user need to explicitly monitor?
So right now, what you saw was the anomaly detection on the raw data, but we are also working on anomaly detection on metrics. So I know we will see something related to business metrics as well when you guys show. But we are using many ML models, and we have business metrics. And the way we are thinking about it is business metrics are also entities, so to speak, in Superglue. So that's our thought process. Just like report is an entity, table and job is an entity. Metric could also be a first-class entity, and we would do anomaly detection on that. And that way you would be able to see the impact of any anomalies in the metric directly off of Superglue as well. I don't know whether that answers your question. No, not all of them automatically. Right now, the way our framework we are looking at is that we would handpick the metrics that need to be monitored, and those are the ones we are monitoring. Yeah, so it's configurable. Thanks. Any more questions? Thank you very much, guys.
Thank you.
Thank you, Sunil and Shraddha. Let's give them a big round of applause. All right. Tonight, we also have awesome speakers from LinkedIn. They're going to talk about the third eye. Third eye is a monitoring framework for real-time monitoring and root cause analysis. Without further delay, let me invite from Sun. Can you help us up?
Good evening, everyone. My name is Xiaohui Sun. So I'm engineer manager of SDI in LinkedIn. So today I'm very happy to here to introduce SDI to you. So before I start, I want to introduce my team. So we have Hardy, Vincent, and Jihao. Come here. Yeah, if you have any question, you can also ask them after the talk. Here's the agenda. So I will first introduce SDI, what is SDI, what's the motivation we build SDI, and I will show how we use SDI in LinkedIn, and then we'll deep dive into the anomaly detection, entity monitoring, and the root cause analysis part in SDI. So here is the life cycle of the incident. So you can see that the earlier we detect the incident and the earlier we recover from an incident, the less business impact it has. So the time between the incident happens and to the incident is detected, this is the anomaly detection part. And the time between the incident is actually detected and people figure out what happened. So this is the root cause analysis part. So we built SDI to reduce the mean time to detect and the mean time to resolve, and then eventually reduce the impact to business. So SDI is a self-service platform that it can enable everyone to efficiently identify and investigate deviation in both business and operational metrics. So why we build SDI? Because in a company like LinkedIn, we have a lot of systems that tangled with each other. So when one issue happens in one system, it's very likely to affect many other systems. For example, when the analysts they see a session count drop in the dashboard, it may be caused by multiple reasons. It may be because the ETL pipelines broken, or it may be because of the schema change, like you already previously said that. It may also be because there are some other experiment is ramping up, so that it may affect the metrics. So previously, in order to figure out what happens, it's people they will come, for example, for analysts, the tracking team, the ETL team, and the experimental team. They will sit together into a war room and figure out what happens. So this is very tedious and not efficient. So what we do is that we build SDI. So we want so this is a single platform, and we pull the integrated knowledge from different systems and pull them together to guide you and help you to do some analysis. Eventually, we want to improve the efficiency of engineering and analysts, and to save the time from the hours, days of war room to actual minutes. So this is how the SDI, the whole data stack in LinkedIn. First, we have tracking data. So everything is injected into Kafka. It's including the the user engagement information and also the system operation metrics. We use Kafka to process it, and then the data is ETL'd into Hadoop. And we have a platform called Unified Metrics Platform. So this is a platform to host all the metrics pipelines. And the metrics, which are the multidimensional and the aggregate data, they're ETL, they're pushed into Pinode. And Pinode is a LinkedIn's open source real-time OLAP engine. So the reason we call it real-time is that you can also directly pull the data from Kafka to Pinode. So it maintains hybrid table internally, and then you can combine the offline and online data together. And SDI will pull the data from Pinode. And besides that, SDI can also pull data from InGraph. So InGraph is our time series data store. So it mainly hosts the operational data, the machine, CPU, disk, and all of other system level metrics. And besides that, SDI can also read from MySQL and Presto because it has a JDBC driver. And SDI pulls all of this data and have some anomaly detection algorithm to detect anomaly. And when anomaly happens, it will send notifications to the user through different channels like email or short message or phone. And upon receive the notification, the user will come back to SDI to do some root cause analysis and to figure out what actually happened. In order to help user to do root cause analysis, we pull the events from different systems. For example, we pull the events from the Jira, which tracks all the incidents. We pull events from the experimentation systems, so it will tell you all the experiment information and how the ramp status. And also we pull the data from deployment and change events. So these events will capture all the major deployment and changes among all the systems inside the LinkedIn. So you may say that okay, it is very good. But how can I use SDI? Currently, SDI is open sourced. So if you search for LinkedIn SDI, you can find the path. In your company, you may not use the Pinode, you may not use the InGraph. But I want to say that SDI is a pluggable architecture. So you can provide your own data source connectors so that you can use it to connect to your data source and to use it to do anomaly detection. And also you can plug in your anomaly detection algorithms. So it has a API so that you can provide the algorithm you like to use. And also for the root cause analysis part, it is also pluggable. You can plug in some root cause modules that pull the events from your systems. So these are the typical users of SDI in LinkedIn. You can see that, for example, site speed team, they use SDI to monitor and analyze the page load time for LinkedIn pages. And the anti-abuse team, they monitor whether the user logging attempts. And the analysts, they use it to monitor the business metrics like the user or use sessions. And the SRE, their operational team, they use it to monitor the PQPS for all the LinkedIn services. And recently we worked with AI so that we use it to track the health of AI models. So I will talk about it later of how we monitor AI models. And there are many more cases, of course. Okay, so let's deep dive into the anomaly detection part. So why anomaly detection is difficult? First, we have so many metrics, and these metrics, they may have multiple dimensions, so which make it very hard to manually monitor all these metrics. And the simple threshold-based or percentage-based rule are not enough because the metrics, they may have the seasonality and trend changes. So this may result in lots of noise and false alarms. And before SDI, we have seen many teams that built their specific solutions, which are not scale and also duplicates of resource. So in SDI, what we are trying to do is first, So instead of using the purely threshold or percentage based, we use data-driven anomaly detection algorithms. So these algorithms are that will learn the trends and impacts of seasonality from your previous data, and it can adapt to the data persistence change. And also it can combine user inputs and use user inputs to improve the underlying algorithm. So these are the specific detection algorithm currently we are using. We use for statistics model, we predict the baseline using an edible model so that it will consider the seasonality and the trend. And for different time granularity data, we have different methods. For example, for the minute level data, we use the sign test. And for daily data, we use spline regression. We also support some traditional statistical models like hot winters. Besides the traditional statistics model, we also use the deep learning sequential models. For example, multi-layer perceptron, ISTM, GAN, and we use this model to detect anomalies for the very complex metrics. So I want to mention that currently the algorithm part is not open sourced in the SDI repository yet, and currently we're working on open sourcing it. In SDI, you can also we provide a very flexible alert configuration. Using this configuration, this is a YAML-based tool. It will help you to define exactly what you want to monitor. For example, we have two configurations. The one is the detection configuration. It defines what to detect, what dimension, what metrics you want to monitor, and also you can define the rules you want to use for anomaly detection. So you can combine multiple rules for this anomaly detection and multiple filter rules. And merger can help to reduce the number of alerts so that it will not overlap. And grouper is a pretty interesting feature. I will talk about it later. So it can help you to more smartly to combine anomalies. And notification configuration is basically tells you when the anomaly happens, what to do, how to notify the users. And from the notification configuration, you can specify the subscribers, and also you can specify suppression rule. Suppression rule is useful when there's a holiday, and you want to suppress a alarm for a while. And you can configure different alert scheme to alert from different channels. So we have an engineer blog talk about it. So you can search for it and to get more information. After you configure all these configurations, we provide an experience called alert preview, so that you can use it to see the performance of your configurations and to see whether this is actually what you want. So that is not only the anomaly detection and sending alerts. It is a whole ecosystem. It provides integrated workflow. So when you see alert, you click and it will go back to SDI, and it will show all the information of your anomaly. And you can also provide feedbacks. You can label these anomalies as a true anomaly or false alarms. And this can help the underlying algorithm to perform better. Okay, I will talk more about the entity monitoring. So entity monitoring is something that we built recently, and we think this is pretty interesting. So why entity monitoring? The first is that currently we have lots of metrics, and normally people they want to monitor on the whole system, but the system has so many metrics. If you monitor all of them, it will generate lots of anomalies, and it's very hard to manage all of them. And also people they tend to use some have some intrinsic logic of these metrics. For example, only alert me when both metric 1 and metric B have anomalies. And also, sometimes this logic might be pretty complicated. We also find it is more meaningful to alert at the scale of system level instead of some single metric level. So that's how we built entity monitoring. So we want to monitor beyond the metrics. So you can see here we have an entity grouper. So when you will have lots of metrics, and then you can put all of these metrics into the entity level, and you can define how to generate entity level metrics from the from single metrics. And also we have a anomaly ranker, so that from the single entity and metric anomalies, you can rank these anomalies and then provide the top anomalies that you most care about. So that using this entity grouper and anomaly ranker, you can reduce the number of anomalies you actually received. So recently we worked with AI team to use this to monitor the AI models. So you can see that from AI machine learning models, each model they have lots of features. So it is very easily that one model has thousands of features or even more features. And if you monitor all of these features, you can think of each feature is a dimension. So this will, for sure, that every day it will generate lots of anomalies. It's impossible to manage. So we use this entity monitoring, and then we provide a customized entity grouper. It will group all of these anomalies and cluster. We have a cluster algorithm to generate the top groups of these anomalies. Then this can help you to review the actual root cause and actual issues. So at the last, I will talk about the root cause analysis part. To detect anomalies, this is not our ultimate goal. So our ultimate goal is that we want to help users to figure out and to find out what is root cause of this anomaly. So this is another important part of SDI, and this is the important feature we provide. So why root cause analysis is difficult? Because first, in order to figure out what happens, this requires human knowledge. But human knowledge is very complicated. It's much complicated than the single relationship model can model. But on the other hand, the human attention is very scarce. That could be very easily overwhelmed by lots of systems. And what SDI provides is that we provide an interactive way, and we use a machine processing and to guide humans to approach the problem to figure out what is the root cause. So I will show you the several screenshots. The first very interesting root cause analysis part is the heat map analysis. So whenever you see your metrics changes, so the first thing is that you want to know which part of your metrics changes. So let's assume this is a matrix has multiple dimensions, and from the heat map, it shows that what is the value distributions of each dimension, and what is the changes of the each value. So we use different color codes to show the changes. So here the red color shows that the matrix decreased, and blue color shows the matrix increased. So use this heat map, you can have an overview of all the distributions and changes of your metrics. So from here, you might find out, okay, although a matrix overall it decreased a little bit, but in US market, actually it increased a little bit. But China market, it decreased a little bit. And then you can click it, for example, click in US, and then it will put in US as a filter. So that the heat map will change dynamically. So it is a dynamic OLAP analysis experience. And also you can choose different colors, color codes, and the different heat maps. For example, you can show the colors based on the absolute change. But absolute change may not make sense for some cases. For example, if your matrix change from 10 to 20, this is 100% change. But it may not affect overall numbers. So you can also choose the changes in contribution, so that it will give you more useful information compared to the absolute change. And our analysts like this tool very much. That even there's no anomaly, they want to use this tool to analyze their data, to take a look at their data and to figure out what happens. Besides this heat map, this is pretty good, but it still has lots of dimensions, that you may need to slice and dice and do some interactive analysis of this dimension to figure out what happened. So what we do is that we have we call it automatic cube analysis that will help you to automatically pop up what is the root cause, the drive of the changes. So we use an algorithm that's called IDIF. So what the algorithm does is that it will consider multiple factors. It will consider the size of the node and the change of this node, and also whether the change is the same direction with the parent, and use all of these factors and to calculate cost function, and then use this cost function to figure out which dimension combinations, which we call it cube, that drives the overall changes. And so for example, you can see here that there are the biggest contribution is the dimension 1 equal to other, and we have some other dimension 2 is equal to all, and dimension 3 equal to all. And for China market, it's drive in a different way. So use this, it can help our analysts, our users to quickly figure out which part of the data changes contribute most. I also want to mention that we're currently writing engineer blog for this algorithm, so stay tuned. So both the heat map and the automatic cube analysis is to analyze the changes within the same metric. But sometimes the metric change may relate to other metrics. So in Sodai, what we do is that you can actually view multiple metrics inside for this data set, and then you can click at this metric, and we will draw these metrics in the dashboard, so you can see what's related metrics. And what's more interesting is that you can add some related metrics. So for example, if you find that you frequently analyze these two metrics together, then you can add a customized related metrics. So this is basically build a knowledge graph of these metrics. And also, at last, I want to introduce this collaborative analysis dashboard. So remember, previously we pulled some events from different systems, and here we use some ranking algorithms and also some related operations, and to figure out the correlation of these system events to this anomaly. You can see here the shaded part is anomaly, and then on below there are the events from different systems. So so we pull the events and rank the events based on their correlation with these metrics. So this correlation is not simply a time correlation, and but we also pull the correlation with human knowledge. For example, take the experimentation events, for example. So we pull all the experimentation that happens around the time range, and then we do a filter to filter on the experimentation that's ramped more than 5%. Because if the experimentation is ramped less than 5%, it is unlikely to affect this metric. And also we pulled the experiments that is likely to affect these metrics from this experimentation system. And these are actually human knowledge. And we pull these experimentations and rank this based on their correlation with this anomaly, and provide an integrated way to visualize their relationship. So if you click the events, it will show all the events in above for you to do analysis. And also you can, of course, you can post some comments on your investigations. So you can say, okay, what causes this anomaly? And you can save this comment and share this analysis to others. So when I open this page, they will see exactly what signals you looked and what is the comment. And also you can show the historical comments of this anomaly. So when this anomaly happened again for this metric, you can see how the previous user, they analyze this anomaly and how this is resolved. Okay, so with all of this, I would like to take questions. Yeah.
So how do you standardize the metrics, right? So you're passing the metric as a single bucket. So I can call cancellation as something. Someone else can call cancellation as something. Do you standardize the metrics in LinkedIn?
Yeah, this is a good question. And in LinkedIn, we have some metrics. We call it certified metrics. So all of these certified metrics you can think of as some standardized, but other people that can build the metrics with a similar name. But for the certified metrics that it will we have in our reporting system and our monitor system, you can differentiate this with other metrics.
Couple of questions. First one, can you talk more about how the entity grouper works?
Okay. Yeah. So let's. Yeah. So entity grouper, it's actually this is also pluggable, so that you can plug in your own logic of how to generate the entities. So for our cases, for example, the AI entity monitoring, so the entity grouper will take all the anomalies generated from the metrics you monitored, and then use this anomalies to generate a high level of entities. So how to define entities is purely your business logic. For example, for here for the AI model monitor, all the feature, we have a concept of feature group. So this higher level of this feature. So this feature group is an entity, and also the model, the whole model is also entity. So from the feature group, we monitor the whole model. Is also entity. But this is this pluggable. You can define your own entity grouper, and as I mentioned, we have a YAML configuration. In the YAML configuration, you can configure which grouper you want to use and which are all the leaf nodes of these metrics. Yeah. Yeah. Yes, in UMP we have tiers of these metrics, so that tier 0 is basically the most important one, and also we have other tiers. For the certified, it's mainly for the reporting purpose. That we have different layers of the importance of reporting. But for metrics, we also have tiers. Yeah. Yes, we basically pull all the metadata of the output. So we have a so you mentioned that from here we pull the data from the pinot, and the pinot data has all the schemas, and we actually pull all the pinot tables and all the metrics from this system.
Thank you for coming and sharing this info with us. Quick question, mostly like a follow-up to Mahesh. So how do we onboard metrics to Third Eye? Does it directly pull all the metrics that are generated by UMP? And
yeah, that's a good question. Yes, for this part, for the pinot part, we automatically pull all the metadata from pinot. And for the in-graph, so this is our time series DB. We have millions of metrics there, so that it's on demand, so that people, when they want to monitor, they need to onboard. So we have a UI to onboard the in-graph metrics.
One more question. So somewhere in the slide, I saw that you're also looking at week over week and year over year. So if you're only getting the metadata, where is the actual data for, say, prior year coming from into Third Eye? Are you generating it on the fly?
Okay. For Third Eye, we do not store the metrics. So when we do anomaly detection, we actually pull the metrics from the different systems. Also, when we do a root cause analysis, we pull the events from system on the fly. We do not store. We only store some metadata like the generated anomalies and the configuration of and also the metadata, the alert configuration, the anomalies and the alerts, and metadata.
Thank you.
So are you saying the user can decide when to run the anomaly detection, or is it run on a schedule like? Yeah,
that's a great question. And in YAML, we have Chrome that you can configure. And currently, we are working on the event-driven or event drive detection, so that you can you can define a Kafka event, and when the event fires, we'll run a detection. This is a work in progress.
Can you, thank you again for the talk. Can you comment on the false positives, both with your anomaly detection and root cause analysis experiences, when this was deployed in production?
Okay. So I don't have a screenshot, but in Sedai, we have a page to show the performance of your alerts. So when you set up alerts, and you can go to this main page, and it will show you how many alerts generated, what is the precision, and what is the recall. So the precision and recall are calculated based on the user labeling. So whenever send alert to the user, and we will gather the precision and recall. And for the false alarm, it is there's a first it is configurable that whether you want to focus on coverage or you want to focus on precision. In the YAML configuration, for example, if you use statistical model, you can configure the p-value. And if you want more coverage, then the precision is not that high. And if you want more precision, and then you may miss anomalies. You may want to find a balance point. That's why we provide a preview experience that you can preview all the settings. And also in Sedai that you can our algorithm will learn from the user labeling. For example, if we generate lots of anomalies and the people that label all of them as a false alarm, then our algorithm will learn that okay, these users they may care more about the precision, so that the algorithm will adapt it and to generate more accurate data, the results.
I have a question about the metric dimension breakdowns. I feel that in that way, it maybe more make sense if that metric is additive. But what if the matrix ratio matrix? Are you using the same logic? Or
yes, that's a good question. First, for the when we show that, you can choose a heat map that's the size of heat map by another metric. So maybe this is a ratio matrix, but you have another metric called count, and then you can still see that okay, this metric have maybe this is a for example click-through rate, but you can still from this graph you can show that in US, if in US this is what is the click count, and then but for the color code you can use the click-through rate or others as a color code. And also for the contribution parts, the cube analysis algorithm, we have an algorithm for ratio metrics specifically. So when we decide which cube or which combination contribute most to the overall change, for ratio we have different handling for ratio metrics.
maybe a follow-up question. So it looks like you have one metric have so many dimensions. This dimension may have a hierarchy structure of this. So how do you decide this metric is anomaly? Are you decide from a top-down decision or from bottom-up decision to decide this metric has some anomalies?
For the anomaly detection, when you configure the alert, you can configure whether this is overall matrix without dimensions, or you can configure it with dimension. If you configure with dimension, then for each dimension, we'll try to detect the anomaly. So by default, we will detect anomaly for all the possible dimensions. It's a combination of, you can think of this, all the combination of this dimension.
But how you decide this metric has anomaly? See, it's possible that there's for example, there's a sub-dimension that have a anomaly, but one anomaly is positive, another is negative. So when you go upper side, so there's no anomaly because they cancel each other. Mm-hmm. So for this case, are you still call this matrix as anomalies, or mm-hmm. using case it is not?
That depends on how you set up this alert. If you set up the only on the top level, then there's no anomaly. But if you set up on the dimension level, it will show anomaly. For example, if you have multiple countries, then if you set up alert to say, okay, I want to monitor each country, then if there are some small country, some other country change has anomaly, it will show us something as anomaly. But we also have a filter called top K, so that you can specify, okay, I only care about top 10 countries I care about. So for other countries, we don't detect anomalies on these countries. We only care about top 10. So it's also configurable.
Thanks for coming and talking. If you go back to your architecture slide, I just had one question. So if you look at, again, the sources, there's different kinds of data structures and data sets, right? You have relational, you have OLAP, you have interactive, you have cubes, right? So as far as the anomalies themselves, how do you normalize these distinct data structures from these different sources?
Yeah, for this, normally we model our data as a hierarchy of first we have a concept called dataset. The dataset can map to a table in MySQL or map to a graph in this graph. And then we have a concept of metric. The metric could be a row that actually contains the actual metric you care about. And we also the metric could be it contains the we also have a concept of dimension. So normally we use the dataset, dimension, and metric to monitor the data model.
Got it. And then the second part, which I think I got it, but I just want to double check. The whole metric, the anomaly detection is fairly contextual because you're not holding state. Right? That's what I understood from. Is there a sliding window or a look back? Because all of this, what you just described, the data set of metrics, dimensions, and those rows to actually even compute the anomaly in the first place, do need some look back or a sliding window in that box there, right? So how is that happening fundamentally?
Okay. First, the look back window. It depends on what kind of detection algorithm you want to use. For example, if the algorithm is just simple week-over-week change, then you just need to look back 1 week. And if this algorithm is the other like spline, for example, we will look back 90 days to. But in Solid, we do not store data, so we will pull the data from pinodes or other systems on demand. And also we store the anomalies. So you can also think of this kind of stateful. So when we detect an anomaly for the current date, we will feed in the previous anomalies into the anomaly detection system algorithm, so that it's also some kind of stateful.
Right. Let's.
I had a couple of questions. So I wanted to understand more how you are accounting for seasonality in the metrics, right? For every business, seasonality is different. For some businesses, it could be just weekend versus weekdays. For some businesses, it would be like every weekday, like they would expect similar traffic on Monday versus Tuesday versus Wednesday, right? So can you talk a little bit more about how you are accounting for seasonality in your models and in detection?
Okay. For the seasonality, what's generally we have the model to learn the seasonality from the historical data. So the underlying data may have different seasonalities, but if this seasonality they are the same for the historically, then the algorithm will learn what is the seasonality it is, and then use this seasonality to build the model. For example, this may be the weekly seasonality, or it's a seasonality of some only have the anomaly, only have a spike at the in Monday or something like this. We have
in your training, do you account for like every weekday as the feature?
As a feature, yeah. a recognized feature.
The other question I had was how are you currently handling, expected anomalies? Basically, you're running a campaign, you're running a promotion, right? You are expected to see anomalies during that window, right?
Mm-hmm.
A lot of times, as an engineer, you're monitoring everything. You find an anomaly, you go to business, and I caught it. You celebrate, right? But then they would say, I knew it. I was expecting it, right? So how are you handling those expected anomalies currently?
First, from the purely anomaly detection system, it doesn't differentiate what is expected anomaly and what is unexpected, because we only look at the time series. But we also have I see there's a slice that we also keep track of how many anomalies is expected. So user they can label whether this is unexpected anomaly or whether they can label whether this is expected anomaly. So it's very small. But for again, also for example, if there's some changes and it will change the metrics, the whole attributes. For example, previously it's something like this, and it will jump. So this is actually this trend change. Then user they can label whether this is a trend change. Our algorithm we have automatically will learn whether there's a trend change. So it will mute the alerts in the future if this is expected or we learn this a trend change. Yeah, but that's basically what we handled here.
I have a question. If you go back to your architecture slide, the question I have is which of these components are pluggable? Say if I want to use third eye, and if you're not using Pinot or InGraph, which components are pluggable? How can I actually use the core components like anomaly detection and root cause analysis with our own systems? Can I do that?
Yeah, that's a great question. So I go here. Firstly, we have three places you can come pluggable. The first is the data source connectors. It can connect to different data sources. So if you use Vertica or use others, but we already have a JDBC driver, so you can directly use Vertica. But if you have other data sources, you can use this. You can write your own data source connector. We have API for it. The second is the anomaly detection algorithm. Currently we are open sourcing our algorithms, but it has built-in algorithm for rules and hot winters. It is already open sourced, but you can plug in your detection algorithms you want to use. The third is the root cause analysis part. You can plug in the events and how you want to rank these events. It's all configurable and pluggable. So that's if you have other system and you want to pull the events from your system, this part is also pluggable.
Good, thanks.
All right. Let's give a big round of applause to all the speakers. Thank you so much.
Thanks everyone for coming, and looking forward to seeing all of you for the next event we'll be having in a month's time or so. Thank you so much. Have a good night.